Homework 8 is the last of the review section. We've kind of jumped all over the place reviewing a whole bunch of things from college algebra. But in this case, we are going to find the roots of my quadratic equation with a leading coefficient greater than 1. Anytime you have a quadratic equation, something with a squared term, you want to set it equal to 0 and make sure it's in the best order, which is descending order. So in this case, the other thing I always want to do is leave my squared term positive. So I'm going to write this as 5w squared. I'm going to add the 17w to move it over and add the 6, and now it's set equal to 0. So I've left my w squared term positive, and then I put it in descending order so it's in the proper order. So one way of solving a quadratic equation is to factor out your expression, and then you can set each of your factors equal to 0. So in this case, we have 5w and w. My signs are both pluses, so a plus and a plus. Factors of 6, I want to get 17, so I want to take 5 times 3 plus 2. 15 plus 2 is 17. So solving each of these, if 5w plus 2 equals 0, I'm going to minus my 2 and divide by my 5. So w is going to equal negative 2/5 for one of my solutions. Over here, if w plus 3 equals 0, w is just going to equal negative 3 because I just have to move my 3 to the other side. So when you put your answers in, you're going to separate them with a comma. So negative 2/5 and negative 3 are going to be your solutions. So number 2, when I'm solving that one, I want to move my 7w over to the other side, but it's got to go between those two things so I have them in the best order. So 4w squared minus 7w minus 2 equals 0. Now we have to be careful with the 4w squared. It might be 4w and w, or it could be 2w and 2w. I'm going to try the 4w and the w. My signs, one is a plus and one's a minus. Might be in another order, but I'm just guessing and checking. Factors of 2, 1 times 2. Checking, my outside plus my inside, negative 8w plus 1w, sure enough, is negative 7w. So I have it factored correctly. And so, either the 4w plus 1 equals 0, or the w minus 2 equals 0. That one's easy to solve. I just add my 2, so I get 2 for my answer. On the other one, I'm going to minus my 1, then divide by my 4, so w equals negative 1/4. And so my two answers, either negative 1/4 or 2, could be solutions. Third one, same kind of thing. I've got a quadratic expression, means I have that squared term. I need to set it equal to 0, so I'm going to move my 5 over. So 3v squared plus 16v plus 5 equals 0. Factoring 3v and v, since both of these are pluses, we have a plus and a plus. Only one set of factors for 5, 5 and 1 or 1 and 5. So if we check it, 15v plus 1v is 16v. So 3v plus 1 equals 0, or v plus 5 equals 0. This one, just minusing our 5. This one, we're going to minus our 1, then divide by our 3, so negative 1/3. So v could equal negative 1/3 or negative 5 for our solutions. 4, 5, and 6 then, now we're solving a little more complicated quadratic solution or equation. In this case, we have the w plus 1 squared. Now in the ALEKS program, they're going to move that over first and put a negative in front of parentheses, and I find that a lot of people miss the sign. So I'm going to do it in a little different order than on ALEKS. I'm going to square this first. So w plus 1 times w plus 1. If we FOIL that out, we get w squared plus 1w plus another 1w plus 1 or w squared plus 2w plus 1. Now again, my shortcut for squaring is to square the first, take 2 times the first times the last, and then square the last. Otherwise, write it down twice and FOIL it out. So 2w squared plus 4w minus 23 equals w squared plus 2w plus 1. Keeping in mind that I want to make sure my w squared is positive, I'm going to move these over here so that I don't end up with a negative w squared. So I'm going to subtract my w squared, subtract my 2w, and subtract my 1. So w squared plus 2w minus 24 equals 0. I'm going to go ahead and rewrite that. W squared plus 2w minus 24 equals 0. Because I have to solve it by factoring again. These ones should be a little easier to factor since we don't have a coefficient in front of our w squared. W and w, a plus and a minus since our end is negative. Factors of 24, that will give me 2. I'd have to have a plus 6 and a minus 4. 6 minus 4 is 2 in the middle. I then have to solve. So if w plus 6 equals 0, I'm going to have a minus 6 answer. And if w minus 4 equals 0, then I have a positive 4 answer because I've got to move my number to the opposite side. So negative 6 and 4 would be my two solutions. Number 5, same kind of thing. I'm going to start by squaring this. So I'm going to take u minus 6 times the second u minus 6. And just to save myself some space, I'm not going to write down this whole thing. I'm going to get u squared, and then I'm going to have a negative 6u and another negative 6u, so negative 12u, and then I'm going to have a positive 36. So 2u squared minus 10u plus 21 equals u squared minus 12u plus 36. Again, we need to set that equal to 0. So we're going to minus our u squared, add our 12u, and subtract our 36. So u squared plus 2u minus 15 equals 0. So factoring that out, u and u, again a plus and the minus since the end is negative. I'd have to have a plus 5 and a minus 3 to get plus 2 in the middle. So that means my answers, if u plus 5 equals 0, I'm going to have a negative 5 because I've got to move that 5 over. If u minus 3 gives me a positive 3, and so negative 5 and positive 3 would be my two solutions. If you need to, set them equal to 0 and solve like you normally would solve, but I think you can do those ones in your head. So number 6, if I'm going to solve that one for x, squaring that, x squared plus 10x plus 25, if you FOIL that out. You get a 5x and a 5x in the middle. Equals 2x squared plus 12x plus 22. So in this one, I need to move those over there. So I'm going to subtract my x squared, subtract my 10x, and subtract my 25. And I would get x squared, another plus 2x, minus 3. Factoring x and x, a plus and a minus, and I'd have to have a plus 3 and a minus 1 to get a plus 2. So my two solutions, if x plus 3 gives me a negative 3 answer, and if I have x minus 1 gives me a positive 1 answer. Negative 3 plus 3 is 0, and 1 minus 1 is 0. And so negative 3 and 1 would be my solutions. The next one says to apply the quadratic formula. It looks like the previous problems where I have a quadratic equation set equal to 0, but try as you may, you're not going to get it to factor out. And so they have the quadratic formula to solve these, and on Alex it will tell you to use the quadratic formula. In real life or in a book, it might just give you the equation and tell you to solve it. I would try to solve by factoring first, but if factoring doesn't work, I can always use the quadratic formula Even on the ones that factor, you can use the quadratic formula. The quadratic formula says if you have ax squared plus bx plus c equals 0. In other words, a quadratic equation where a is the coefficient of your x squared, b is the coefficient of your x, and c is your constant term, that x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so basically all we're going to do is plug in the a, b, and the c based on the values that we have in our quadratic equation. So a is going to be 2, b is going to be a negative 9, and c is going to be 5. So in my quadratic formula I have minus the b value, which is negative 9, plus or minus the square root of the b value, which is negative 9 squared, minus the number 4, times the a value, which is 2, times the c value, which is 5, all over 2 times the a value, which is 2. So I filled in my a, b's, and c's. Notice I do have a 4 and a 2 that's always going to be in my formula. And now I want to simplify. If I have minus a negative, that's going to make that a positive 9. Negative 9 squared. Negative 9 times negative 9 is 81. Negative 4 times 2 times 5. That's going to give me negative 8 times 5, so minus 40. 80 minus 40 gives me the square root of 41, then, simplifying everything under my square root. All over 2 times 2, which is 4. On Alex, they don't have a plus or minus button, so you have to put it in as 2 answers. Be careful, this is one big fraction. Hit the fraction button first. So 9 plus the square root of 41 over 4, and 9 minus the square root of 41 all over 4 are going to be your solutions. So number 8, if I'm going to use my quadratic formula there, a is 9, b is negative 5, c is negative 1. So minus the b value plus or minus the square root of the b value squared minus 4 times the a value times the c value all over 2 times the a value, and then I'm going to simplify. So again, I have minus a negative 5, which is a positive 5. On my square root, a negative 5 squared is 25. Negative 4 times 9 times negative 1 would be positive 36. So adding those together, I get 61. And then 2 times 9 is 18. So 5 plus the square root of 61 over 18, and 5 minus the square root of 61 over 18. Going to be the 2 solutions that you have to type in. What I do is use my word shortcut, so I type in the first one, and then I highlight it, Control-C copies, Control-V pastes, and then I just change the middle sign from a plus to a minus. So 5 plus or minus the square root of 61 over 18. Number 9 then, if I'm going to use my quadratic formula, a is going to be 3, b is going to be 3, and c is going to be minus 7. So I'm going to have minus the b value plus or minus the square root of the b value squared minus 4 times the a value times the c value over 2 times the a value, putting my numbers in for my a, b, and c. So in this case, I'm going to have minus 3 plus or minus. 3 squared is 9. Negative 4 times 3 times negative 7. 4 times 3 times 7 is 84, and it's going to be negative, positive. Negative times a negative. I was going to say that's in the wrong section if it's a negative, but we have a negative times a negative. So we get a positive 84 plus our 9, so we're going to have 93 over 6. So we have negative 3 plus the square root of 93 over 6, and negative 3 minus the square root of 93 over 6. Be careful on this one that you do get the negative on the top of the fraction. So again, hit the fraction button first and then type it in. We didn't have any that we could simplify, but sometimes you'll get the square root of 18, say, that you can factor and then you can simplify it further. The only way you can reduce it down is if all 3 terms are divisible by the same thing. And so if I would have been able to factor out a 6 or a 3 there, I could have reduced, but since I can't factor it out any farther, that's just going to be my answer. Now the next 3 say that you're finding the complex solutions, which again tells me I'm probably going to use the quadratic formula, but this time I may or may not end up with imaginary numbers. Most of the time you will, but sometimes they throw in one that's just a real number, because technically that's a real number plus a 0i, which is a complex number. So when it says to find the complex solutions, again, we're going to use our quadratic formula. And so we're going to plug our numbers in and go ahead and solve. So if I have x squared minus 5x plus 7, a is going to be equal to 1, b is going to be equal to negative 5, c is going to be equal to 7. So I'm going to have minus my negative 5 minus the b value of negative 5 plus or minus the square root of negative 5 squared minus 4 times the a value of 1 times the c value of 7 all over 2 times the a value. So since I have minus a negative, it becomes positive 5 plus or minus here. This is going to give me 25. This is going to give me minus 28. So I have the square root of negative 3 over 2. So this has a negative in it. I have to take the I out of there. So I'm going to have 5/2 plus or minus the square root of 3 over 2, and the I is going to go behind there. Notice again on that square root, the square root is over the 2, or over just the 3, not over the 2. The 2 is a nice whole number 2. And so again, hit the fraction button first, type in the square root of 3 over 2, and then the I goes behind your fraction. Again, on Alex, they're going to make you put in 2 separate answers. So 5/2 plus the square root of 3 over 2i, and then 5/2 minus the square root of 3 over 2i. Now these ones don't say that you have to put them in standard form. So if you did put them at one big fraction, it's still going to work. But this is what it would look like in standard form. So number 11, again, I'm going to use my quadratic formula. This time, a is going to equal 8, b is going to equal 1, because that's a 1x, and c is going to equal 2. So I'm going to have minus the 1 plus or minus the square root of 1 squared minus 4 times the a value, which is 8, and the c value, which is 2, over 2 times the a value. So this is going to be negative 1 plus or minus the square root of, this would be 1, and that's going to be minus 64, so I'm going to have a negative 63. So simplifying this, 63 is 9 times 7, I'm going to have 3i, or I'm going to put it this way, 3 square root of 7i then, right? And so I'm going to have negative 1/16 plus 3 square root of 7 over 16i, and 1/16 minus 3 square root of 7 over 16i, if I put them in standard form. Number 12. Simplifying my quadratic expression again. A is going to equal 1, B is going to equal 5, and C is going to equal negative 5. So negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 5 over 2 times 1. So negative 5 plus or minus. This would be 25. This would be plus 20. So that'd give me the square root of 45 over 2. So on this one, we don't have the imaginary number part, but we can simplify this into 9 times 5, which is 3 square root of 5. So I'm going to have negative 5 plus 3 square root of 5 over 2, and then negative 5 minus 3 square root of 5 over 2. Again, they're going to make you put it in 2 separate answers. There's no plus or minus, but that one doesn't have an imaginary number part, so I'm just going to put my real number answer. You'll get both kinds, most of the time the imaginary ones. 13, 14, 15, we're going to use the quadratic equation again to solve, but this time we are going to convert our quadratic equations into decimal answers. So it says when a ball is thrown, its height in feet h after t seconds is given by the equation. H equals vt minus 16t squared, where v is the initial velocity in feet per second. If v is 23 feet per second, find all the values of t for which h is 8 feet. So I'm going to put an 8 in for the h and a 23 in for the v. So I have a quadratic equation, but I want to put it in its best form, so I'm going to set it equal to 0. I also like to make sure my t squared is positive, and so I'm going to move these two things over here. So 16t squared minus 23t plus 8 equals 0. So using my quadratic formula, A is going to be 16, B is going to be negative 23, and C is going to be 8. So I'm going to have minus a negative 23 plus or minus the square root of negative 23 squared minus 4 times the A value of 16 times the C value of 8 over 2 times the A value. So simplifying that, we're going to have 23 plus or minus, and then I've got to figure out that part under the square root. So a negative 23 squared would be 529. Negative 4 times 16 times 8 is minus 512. And so that's going to give me 529 minus 512, square root of 17 over 32. So when I solve this, on my calculator, I have to do the top part first. So in parentheses, I'm going to do 23 plus the square root of 17, and then I'm going to divide it by 32 and hit equals. If I don't use these parentheses, I have to hit equals here, then divide by 32 and hit equals again. But easiest thing to do is just use your parentheses around that top part, and then we're going to find our two solutions. So 23 plus the square root of 17 divided by 32, rounding to 2 decimal places gives me 0.85. I have 0.847, so I rounded off to 0.85. And then 23 minus the square root of 17 divided by 32, rounding to 2 decimal places, 0.589 goes to 59 then. And so those are going to be my two answers. Because when I throw my ball up, it's going to go up, curve, and come down, so twice it should be at that same height of 8 feet. Number 14, same kind of thing. A ball is thrown from an initial height of 2 meters with an initial upward velocity of 25 meters per second. The height h in meters after 2 seconds is given by the following. Find all values of t for which the ball's height is 7 meters. So, my height is 7. I'm going to put a 7 here. 7 equals 2 plus 25t minus 5t squared. Again, I have to set that equal to 0. I'm going to move these over here. So this is going to be a positive 5t squared. This will be a negative 25t. And I have to subtract my 2 from my 7. So that would be plus 5 equals 0. So in my quadratic formula, I'm going to have minus a negative 25 plus or minus the square root of negative 25 squared minus 4 times 5 all over 2 times 5. So using A, B, C, plugging them into my quadratic formula. So this gives me positive 25. So a negative 25 squared gives me 625. Four times 5 gives me 100. So 625 minus 100, 525 over 10. So again, I'm going to do 25 plus the square root of 525 divided by 10, and then 25 minus the square root of 525 divided by 10. Make sure you use the parentheses or hit equals after that first part before you divide by the 10. So 25 plus the square root of 525 parentheses divided by 10 gives me 4.79 when I round to the nearest hundredth. And then if I do 25, parentheses first, 25 minus the square root of 525, close my parenthesis, divided by 10, I get 0.21, because I have 0.208, so round that off to 0.21. So again, I'm going to have 2 times where my height is 7 meters at 4.79 and at 0.21. And number 15. Now this time I have a ball that is thrown from the height of 44 meters. I'm up on top of this building with an initial downward velocity of 6 meters per second. The height h in meters after t seconds is given by the following. H equals 44 minus 6t minus 5t squared. How long after the ball is thrown does it hit the ground? So, if it hits the ground, I'm laying on the ground, my height is going to be 0. Because the height is in meters above the ground. So 0 equals 44 minus 6t minus 5t squared. In best form, I would use 5t squared plus 6t minus 44 equals 0 then. Now with quadratic formula, you could probably get by with that negative t squared, but it's always a good idea to make your t squared positive so things turn out nicer. So I'm going to have minus my b value of 6 plus or minus the square root of 6 squared minus 4 times 5 times negative 44 over 2 times 5. So this is going to give me negative 6 plus or minus the square root of, that's going to give me 36. And then I'm going to have to do 4 times 5 times 44, which is 880, and that's going to be a plus. So plus my 36 will give me 916 over 10 again. So I'm going to do negative 6 plus the square root of 916 divided by 10, and negative 6 minus the square root of 916. negative 6 plus the square root of 9/16 divided by 10 gives me 2.43, 2.426. All right, and then if we do our other calculation here, in parentheses, negative 6 minus the square root of 9/16 divided by 10. And I get negative 3.63. Now, in this case, when I throw it off the top of the building, there's only going to be one time where it hits the ground, at least unless it's bouncing around. But we just want to know when it's going to hit the ground. So although we got this answer, we know we can't have a negative time. We're just going to use the one answer. So 2.43 would be the only answer we'd enter in. 16, 17, 18, solving a radical equation. And so now we're getting into simplifying things with square roots. It'll be later cubed roots or fraction exponents. And then we want to isolate that term first and then do the opposite of what we want to get rid of. In this case, we want to get rid of the square root. So we're going to do the opposite of the square root, which is squaring. So first thing we want to do is get this by itself. So I'm going to add my 2 and move that over. So 3 is equal to the square root of 5b minus 16. Now I can get rid of the square root since it's by itself by squaring both sides. 3 squared is 9. When we square a square root, it cancels out, so we get 5b minus 16. So we're going to add our 16 to move that over to the other side. So 9 plus 16 is 25. So 25 equals 5b. And when we divide by 5, then b equals 5. Now you do get what's called extraneous solutions, so you always want to check your answers. 5 times 5 is 25. 25 minus 16 is 9. The square root of 9 is 3, and 3 minus 2 is 1. So this one does check out. It is okay. But you always want to make sure you go back and check, because sometimes what happens is you end up squaring a negative, and then the answer will not check. It's called an extraneous solution. So if I do the next one, I'm going to subtract my 4. I get the square root of 2w minus 11 equals negative 1. Here's one where I'm going to get my extraneous solution. I'm going to go ahead and finish solving. Squaring both sides, 2w minus 11 equals a negative 1 squared, which is a positive 1. So I'm going to add my 11. 2w equals 12, and divide by 2, w equals 6. But when I go back and check this one, 2 times 6 is 12. 12 minus 11 is 1. The square root of 1 is still 1, and 1 plus 4 is 5, not 3. So this answer is not going to check. You're going to get no solution. And that's going to happen a lot of times when you square that negative, because a square root can't equal a negative number anyway. Number 18. So number 18, on this one, the square root is already by itself, so we just have to square both sides. 6 squared is 36 equals 9 minus 3y then. I'm going to subtract my 9. So 36 minus 9 would be 27. 27 equals negative 3y. And divide by negative 3, so y equals negative 9. So negative 3 times negative 9 would be 27. 27 plus 9 is 36, and the square root of 36 is 6. That answer is okay and checks out. But also make sure you go back and check your answers whenever you're working with radicals. So 19, 20, and 21, again, we're simplifying a radical. You want the radical by itself, which it is, but when you square both sides, you're squaring the entire side. So you can't just square the x and square the negative 2. You have to FOIL it out. So when you square your square root, you get 32 minus x. But on this side, if I FOIL that out, I'm going to get x squared. I'm going to get a minus 2x and another minus 2x, which is minus 4x. And then a negative 2 times a negative 2 is a positive 4. So we end up with a quadratic expression. We want to set it equal to 0 and solve that. So I am going to subtract my 32 and add my x. So I get x squared minus 3x minus 28. And then solve by factoring. X and x, plus and a minus. Factors of 28, 4 and 7. I'd have to have a minus 7 and a plus 4 in order to get minus 3 in the middle. So if x plus 4 equals 0, that's going to give me a minus 4 answer. If x minus 7 equals 0, it gives me a positive 7 answer. Again, you have to go back and check those answers because sometimes you get extraneous solutions. So if I put the negative 4 in, 32 minus a negative 4 is 36. The square root of 36 is 6. Negative 4 plus negative 2 is negative 6. Well, 6 doesn't equal negative 6. That answer doesn't check. So then I'm going to try the 7. So 32 minus 7 is 25. The square root of 25 is 5. And 7 minus 2 is also 5. That one's going to check, so on this one, we're just going to count the one answer, x equals 7. Number 20, same kind of thing. The square root is already by itself. I'm going to square both sides, so FOILing that out, I would get w squared plus 2w's plus 1. And if you need to, write down w plus 1 plus w plus, or times w plus 1 and FOIL it all the way out. Squaring the square root cancels that out. So 28 minus 4w. Again, I want to set it equal to 0. I want my w squared to be positive. So I'm going to minus my 28 and add my 4w. So w squared plus 6w minus 27 equals 0. So w and w, negative and a negative, factors of 27 that add up to 6. Oh, wait a minute. Nope. The end is negative. I'm losing my mind here. Okay. The end is negative. I should have a positive and a negative. I was trying to figure out how I was going to add up to 6 with two negatives. It won't work that way, will it? But it will if I use the right signs. So a positive times a negative is a negative. 9 times 3 is 27. Positive 9 minus 3 gives me plus 6. So if w plus 9 equals 0, I'm going to get a negative 9 answer. If w minus 3 equals 0, I get a positive 3 answer. And again, if I check these, negative 9 plus 1 is negative 8. Negative 4 times negative 9 is 36. 36 plus 28 is 64, and the square root of 64 is a positive 8, not a negative 8. So the negative answer isn't going to check. 3 plus 1 is 4. Negative 4 times 3 is minus 12. 28 minus 12 is 16. Square root of 16 is 4. So the only answer on this one that works is the 3. And if we do number 21, let me move the board up here. I'm going to solve that. Again, I'm going to square both sides. So y squared minus 6y plus 9 is what I get if I FOIL that out. Is going to equal 3y minus 11. So I'm going to minus my 3y and add my 11. So y squared minus 9y plus 20 equals 0. So y minus 5 and y minus 4 would give me a minus 9 in the middle. Which means if y minus 5 equals 0, I get 5 for my answer. If y minus 4 equals 0, I get 4 for my answer. So checking those. 5 minus 3 is 2. Here I would get 15 minus 11, which is 4, and the square root of 4 equals 2, so the 5 works. 4 minus 3 is 1. 3 times 4 is 12. 12 minus 11 is 1. The square root of 1 is still equal to 1. So in this case, both of my numbers check and are okay. Have you seen? The positive ones work, the negative ones haven't worked. And the last three here, solving an equation with a root greater than 2, fourth roots, cubed roots. If it's an even root, you need to check your answer. If it's an odd root, it's not going to matter because the positive and the negative thing don't go into effect like it does when you square a negative, it turns positive. But what we want to do is isolate our radical expression. So in this case, I'm going to minus my 1 first. The fourth root of 2x plus 2 equals 3 minus 1, which is 2. Then I'm going to do the opposite of whatever that root is. This is the fourth root, so I'm going to raise to the fourth power. That's going to cancel this out. I get the 2x plus 2. Over here, 2 to the fourth is 16. So I'm going to subtract my 2. 2x equals 14, and divide by 2, x equals 7. So 2 times 7 is 14. 14 plus 2 is 16. The fourth root of 16 is 2, and 2 plus 1 is 3. So that is going to check out. I get an answer of 7. On the next one, I've got radicals on both sides, but fortunately they're both cubes. So I can go ahead and cube both sides. 3x plus 8 equals 6x plus 2. So I'm going to subtract my 6x and subtract my 8. And so I get negative 3x equals negative 6. And so when I divide, x equals 2. So what I'm looking for is, do I get the same number under both of those? I don't really care what the cubed root is because they're both under cubed roots. So 3 times 2 is 6. 6 plus 8 is 14. 6 times 2 is 14 plus 2 is also 16. Or 14, yeah, let me do that again. 3 times 2 is 6. 6 plus 8 is 14. 6 times 2 is 12. 12 plus 2 is also 14. So the cubed root of 14 equals the cubed root of 14. And so my answer is going to be all right. And so number 24, same kind of thing. I need to move this over to the other side. So the fourth root of 8x minus 7 is going to equal a negative 3. I then have to take it to the fourth power. So 8x minus 7 equals negative 3 to the fourth, which would be positive 81. So 8x is going to equal, I'm going to have to add my 7, so that's going to give me 88, and divide by my 8, x equals 11. If I check that out, 8 times 11 is 88. 88 minus 7 is 81. The fourth root of 81 is 3, and 3 plus 3 is 6, not 0. So I have to say, oh, no solution. The fourth root can't equal a negative anyway because it has to be positive. The last three, we are solving ones that have fractional exponents. And these are just like we have the radical sign. But to get the point across is what we're doing is we're getting rid of the 1/4 by multiplying by the reciprocal, which is a 4th power. So again, I've got to get this by itself. So I'm going to minus my 3 and say 3x plus 1 to the 1/4 power equals 5 minus 3, which is 2. since this is the fourth root, I'm going to raise both sides to the fourth power. 1/4 times 4 just gives us that 3x plus 1. So it works the same way we did when we had the radical, since we have that unit fraction there. But what you're really doing is multiplying by the reciprocal. 2 to the fourth power is 16. So I'm going to subtract my 1. 3x equals 15 and divide x equals 5. So 15 plus 1 is 16. The fourth root of 16 is 2, and 2 plus 3 is 5. Yes, that checks out. Same kind of thing here. This is already by itself. I'm going to take each side to the third power. And so in this case, I'm going to get 5u plus 12 equals negative 2 to the third would be negative 8. I have to subtract my 12. So 5u equals negative 20 and divide u equals negative 4. Now here we have an odd exponent, so we should be okay. 5 times negative 4 is negative 20. Negative 20 plus 12 is negative 8. And the third root of negative 8, sure enough, is negative 2, right? The cubed root, the third root of negative 8 is negative 2. So that checks out okay. And so, if we look at number 27 here, again we have the fourth power, but we've got to get it by itself. And so 3w plus 16 to the 1/4 equals negative 1. Well, again, hopefully you know that the fourth root can't equal a negative, but if we go through the process of solving, I would raise this to the fourth power. That cancels that. 3w plus 16 equals a positive 1, because a negative 1 to the fourth is 1. I would subtract my 16, so 3w equals negative 15 and divide by 3. W equals negative 5. But if I would check that out, 3 times negative 5 is negative 15, plus 16 is 1. The fourth root of 1 is still 1, and 1 plus 8 is 9, not 7. So we get a no solution. Now, all of ours were unit fractions where you had 1/4 and 1/3. If you would have something like 2/3, you'd have to do the 3/2 power. You have to do the reciprocal of that fraction.